Welcome Algebra 1 class. Today we're going to be looking at Activity 1, Lesson 1-1, Investigating Patterns, with a theme of cross-country adventures. Our learning targets, what we're shooting for, is being able to identify patterns in data. So when they give you a bunch of numbers, we want to be able to look at those numbers and see what's happening to them. Are they increasing or decreasing? Are they being multiplied or divided? Or is it some kind of combination of all of those? And all of those situations can happen. We want to be able to use tables, graphs, and expressions to model situations. So sometimes when they give us the data, we want to be able to put it into an easier to read format. That's the good thing about tables and graphs and using expressions to shorten it basically from the situation that we're in or being given and shortening it to one of these three. We also want to be able to use expressions to make predictions. So if we can write down what's happening in a mathematical way, we can then use that to predict what will happen in another situation that may occur later on or has already occurred. Some of the strategies that we will be able to use are sharing and responding. A little tricky when it's just me talking to a video recorder and you watching it, but there are ways for you to share and respond on the Google Classroom. Create representations, discussion groups, again, tricky when we're not even allowed to be together sometimes. Look for a pattern, and interactive word walls. So sometimes you'll need to write down words and kind of make connections in your notebook with what's happening. Meising spent his summer vacation traveling cross-country with his family, so they basically just went on a trip. The first stop was Yellowstone National Park in Wyoming and Montana. Yellowstone is famous for its geysers, which is where the water kind of shoots up from the ground. Especially one of them most commonly referred to as Old Faithful. A geyser is a spring that erupts intermittently, forcing a fountain of water and stream from a hole in the ground. So basically what I just said. You see I don't read ahead sometimes. Old Faithful can have particularly long and fairly predictable eruptions. As a matter of fact, park rangers have observed the geyser over many years and have developed patterns they use to predict the timing of their next eruptions. For example, let's look at this chart. We have the length of eruption in minutes. So the eruption might be 1 minute long, 2 minutes, 3 minutes, 4 minutes, and the approximate time until the next eruption in minutes. So if that eruption was 1 minute long, it was 46 minutes until the next eruption happened. If the eruption of water was 2 minutes long, it took a little bit longer and went up to 58 minutes before the next eruption, and so on. 3 to 70, 4 to 82. Describe any patterns you see in the table. So let's look at this. When I look at this, I see that this number of minutes of length of the eruption is increasing by 1. Over here, on the approximate time to the next eruption, for every 1 minute long, it looks like, well, there's a difference of 12 minutes added to it each time. So if it was 1 minute long, 46 minutes until the next eruption. 2 minutes long, 46 plus 12 is 58 minutes. 3 minutes long, add another 12, we get 70. So plus 12 seems to be our pattern. And that's what we would write in our notes or in our book or on this website if you're using it to help you. An increase of 12 minutes for every 1 minute the eruption lasts. Let me increase this just a little bit. An increase of 12 minutes between eruptions. it's always okay to go back and fix something if you don't happen to get your complete thoughts the first time. That's just an example of an answer. You don't have to put it exactly like that. It could be however you say it, as long as you have the basic concepts. For every 1 minute the eruption lasts, it takes another 12 minutes between the eruptions. 2. Why might it be important for park rangers to be able to predict the timing of Old Faithful's eruptions? This is more of a you kind of question. Why do you think it's important to be able to know when the eruptions are going to happen? For example, it could be to provide for the safety of others who happen to be visiting. You wouldn't want to be around these eruptions. These eruptions are usually very hot, like boiling kind of temperatures. That's what causes the water to come out at those times. Now there are other ones you could say that this helps for people to come and see and know when things are going to happen. Again, it's a you kind of question. Number 3, if an eruption lasts 8 minutes, about how long must park visitors wait to see the next eruption? And explain your reasoning using the patterns identified in the table. So, if we look at this, we saw that 1 minute was 46, 2 was 58, 3 was 70, 4 was 82. All right, we want to go up to 8 minutes. And we could just write that down and make the pattern of the table just extend it another, like we could go 5 and 94, 6 and 106, 7 and 118, 8 and 130. That's the answer, 130. And we got that by just extending the table and the pattern that goes along with it. Let's go ahead and look at number 4, graphing the table using the data that we already have given to us. We're going to mark basically the chart onto this graph. So 146 would be about here. 258 would be around here. 370 right about here. And 482 would be around here. That's all it was asking me to do, graphing the table. You'll notice that it makes a line that's going up, increasing. Number 5, Meising and his family arrived at Old Faithful to find a sign indicating that they had just missed an eruption and that it would be approximately 2 hours before the next one. How long was the eruption that they missed? And explain how we determined our answer. All right, let's go back up to the chart. Like we said before, if we want to predict in the future, one way that we could do that is to extend the chart, the table, the pattern that goes along with it. And we want to get to basically the 2 hours until the next one. And we're at 1 hour and 12 minutes at 82. Sorry, 1 hour and 22 minutes. So we're going to extend. So let's say once it gets to 5, another 12 minutes would make that at 94. That's 1 hour and 34 minutes. 6, another 12 minutes would make that 106. 7, another 12 minutes would be 118. Remember, 2 hours in minutes is 120 minutes, so it's going to be just a little bit over 7. 8 minutes, 8 of eruption length would be a little bit too long, since that would be 130. We needed 120, so it's between 7 and 8 minutes long eruption, and that'll tell us that we need to wait between 118 and 130 minutes, which we wanted 120. So 120 would be somewhere in between there. So let's see, number 5. How long was the eruption that they missed? It was about a little over 7 minutes. Remember, all of these are also approximate. That means about. So, around 7 minutes. There it is. A little over 7 minutes. And explain how you determined your answer. We found this by extending the table. All right. Number 6, patterns can be written as sequences. Now, sequences are just a list of numbers. Okay, just a list of numbers. So we're going to write, using the table or graph above, we're going to write the approximate times until the next Old Faithful eruption as a sequence. We're just going to write it down as a list. Let's just look at what the list is. Until the next eruption: 46, 58, 70, 82. 46, 58, 70, 82, and so on. We'll just keep going. That's a sequence. That's a list of numbers. How would you describe this sequence of numbers? Well, we've already done that, I think, before, so let's look at it one more time. What do we notice about this list of numbers? It is increasing by 12 minutes. Okay, remember, starting off pretty simple so far on this lesson. In the table below, 5 and 8 are consecutive terms. Now, consecutive just means it's one right after the other. Okay? In this table below, 5 and 8 are consecutive. 5, the next number is 8. That's consecutive. 5 and 11 are not consecutive. They're not right after the other. 8 and 11 are consecutive. 11 and 14 are consecutive. 5 and 8 are consecutive. Consecutive, one right after the other. Remember, a lot of vocabulary, but that's part of it. Some sequences have a common difference between consecutive terms. The common difference between the terms in this table below is 3. 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. Identify 2 consecutive terms in the sequence for the next eruption that we created in item 6. Here's our sequence that we listed for the next eruptions. Find 2 terms that are consecutive, that are right next to each other. Let's say 58 and 70. That's a good pair. Why not? So 2 consecutive terms, 58, 70. It's not the only pair. You could have said 46 and 58. You could have said 70 and 82. It just asked for 2 consecutive terms. One pair of 2 consecutive terms, basically. That's what I mean. Number 9. The sequence of next eruption times has a common difference. Identify the common difference. Now, we've identified this multiple times already. The difference, the change between the numbers that we were looking for, 58 and 70, okay, right here, We've said it multiple times. It's just trying to get you to remember that this is what we're talking about. The sequence has a common difference of 12 minutes. Okay, not hard. Number 10. Each term in the sequence above can be written using the first term and then repeated addition of the common difference. Remember what the common difference was? Right there. The first term, we go back up to the very chart that we're talking about. First term until the next eruption was 46. So writing the approximate waiting time for the next eruption after eruptions lasting 4 to 5 minutes using repeated addition. We're going to go in and we're going to write it at 4 minutes. Okay, let's see, 4 minutes. Well, we have 46 is our starting number. And then we add 12 to it. Plus 12 one time, 12 two times, 3 times, 4 times. Four times. This is the first one, second, third, fourth. I went a little bit too far. I had to erase it. And what is 46 plus 12 plus 12 plus 12? That's the same thing as 46 plus 12 times 3. It's the same thing as 46 plus, hard to use this keyboard, 46 plus 36. That's just me fat fingering keys. 46 plus 36 equals 12. 6 and 6 is 12. Add the 1, carry it. So that'll be 82. Next, it also wanted at 5 minutes. 5 minutes. We just do the same thing, so we will have 5 terms. 46 plus 12, 12 plus 12 plus 12 plus 12. 1, 2, 3, 4, 5. It's the same thing as 46 plus 12. That is equal to 12 times 4 is 48. 46 plus 48. Well, 8 and 6 is 4. You carry the 1, 14. Carry the 1. 1 and 4 is 5, plus 4 is 9. 94. Part B. Let n represent the number of minutes an eruption lasts. Write an expression using the variable n that could be used to determine the waiting times until the next eruption. So if we don't want to have to add it up all the time like we did, we want to be able to use an expression so that no matter what time they give us, we could figure it out. So let's see. We know our starting point is 46. All starts there. And we know that we're going to add 12 to it. And the number that we multiplied times 12 was the number of minutes, but not exactly. It was minus 1 because we already had that first minute accounted for as 46. So it would be the number of minutes, variable n, minus 1. It would look like that. 46 plus 12 times n minus 1. All right. Check the accuracy of your evaluation by evaluating it when n is 2. So if I put in 2 for the n, it would be 46 plus 12 times 2 minus 1. Okay, that's 46 plus 12 times 1. 46 plus 12, and that would be 58. Checking that the second one was 58 in our chart. The second one was 58. Very good. We got it right. D, use that expression to determine the number of minutes a visitor to the park must wait to see another eruption of Old Faithful after a 12-minute eruption. We're just going to plug in 12 this time. Same process. 46 plus 12 times the number of minutes that we're waiting, 12 minus 1, because we already took care of that first minute, is equal to 46 plus 12 minus 1 is 11, equals 46 plus 12 times 11. All right, 12 times 11 is 132. 46 plus 132, which equals, let's see, 6 plus 2 is 8. Carry 4 plus 3 is 7. 178. I'd like you to try numbers 11 through 21 on your own. Okay, you're going to check for your understanding. You're going to make a chart based on the information they give you. Put it on the table, write a sequence, just follow along. Go back and look at the work that we've already done. But let's try 11 through 21 on your own. And that would be the end of the first lesson. Thanks for learning with me.